Assalamu alaikum girls. I am Shamsunnisa from Royal Degree College, Chemistry Department. Today in Unit 2 Organic Chemistry, amines, cyanides and isocyanides, we are talking about chemical properties of amines. First property is alkylation. Primary amine, that is methenamine, react with methyl bromide in presence of ammonia base, forms dimethylamine, that is the secondary amine. CH3NH2 methylamine, in that we are adding methyl bromide, so we are getting an addition compound, that is CH3 taken twice NH2 plus Br minus. In this we are adding base. So what will happen from this addition compound, one hydrogen and Br, it is coming out as a hydrogen bromide, and our main compound what we are getting is CH3 taken twice NH, which is named as dimethylamine. When dimethylamine, secondary amine, react with methyl bromide in presence of base, forms tertiary amine, which is named as trimethylamine. So we are taking dimethylamine, CH3 taken twice NH, in that we are adding methyl bromide. So what will happen here? This methyl bromide is added to the dimethylamine. So we are getting here CH3 taken twice NH plus Br minus. In this we are adding ammonia base. So what will happen? This HBr, it is coming out as a side product, and our main product is CH3 taken thrice N, that is named as tertiary methyl, or the trimethylamine we can say, it is named as tertiary amine. Next is when trimethylamine, that is the tertiary amine, react with methyl bromide to form ammonium salt, that is tetramethyl ammonium bromide. So we are taking trimethylamine, that is nothing but tertiary amine. It is reacting with methyl bromide. So we are getting this addition compound, CH3 taken 4 times N plus Br minus, tetramethyl ammonium bromide, which is nothing but ammonium salt. The reaction between an amine and methyl halide to form quaternary salt is called exhaustive methylation. Second property we will see of amine, acylation. Primary and secondary amines react with acid chloride to form N-substituted amide. The process is called acylation. Tertiary amine cannot be acylated. See, here we are taking C2H5NH2, which is named as ethylamine. In that we are adding CH3COCl, acetyl chloride. Then what will happen? One hydrogen from ethylamine coming out, reacting with Cl of acetyl chloride, and we are getting HCl. And our main compound is C2H5 and H remains there. Okay. In that COCH3 is added, and we are getting C2H5 and HCOCH3, which is named as an ethyl acetamide. Second reaction we'll see, dimethylamine we are taking, which is nothing but secondary amine. In that we are adding acetyl chloride, CH3COCl. So one hydrogen from dimethylamine reacting with Cl of acetyl chloride, and we are getting HCl. Then what is remaining there in the dimethylamine? CH3 taken twice and H. Okay. So here this particular thing, it is added to the CH3CO. So we are getting here CH3CO and CH3 taken twice, which is named as N-dimethyl acetamide. Now we will see the mechanism. Primary amine act as a nucleophile and attack the carbon atom of acetyl chloride. See here, we are taking acetyl chloride, CH3, single bond C, double bond O, single bond Cl. So what will happen here? When the bond in between carbon and oxygen, double bond is there. Now one bond when it is shifted towards the oxygen, oxygen is carrying a partial negative charge. And at the same time, Cl is carrying a partial negative charge. And as the bond is shifted towards the oxygen, the carbon is electron deficient, so it will carry a partial positive charge. This is acyl chloride. Okay. In this, we are adding ethylamine, that is CH3, CH2, single bond N, single bond S, single bond H. On nitrogen, lone pair of electron we are representing. So this pair of electrons which are present on the nitrogen of ethylamine, it is forming a bond in between nitrogen and carbon. So we are getting this particular product. Okay. So on nitrogen we are representing a positive charge, and on oxygen 2 electrons with the negative charge. That product, it is becoming a reactant in the next step. So we are taking that compound. Now what is happening here? This pair of electrons are there on the oxygen. This electron pair, it is forming a bond in between carbon and oxygen. So double bond here we are representing. At the same time, the chlorine along with the bond, it is coming out. Okay. So the chlorine with the negative charge here we are representing. Cl, 2 electrons with the negative charge. Rest of the things are as it is. Next step is we are taking the previous product as a reactant, and what will happen here in this particular reactant, in between nitrogen and hydrogen single bond is there. Na? One of the bond, it is shifted towards the nitrogen, and hydrogen, it is coming out without bond, without electron. It is coming out. It is becoming electron deficient. So what will happen as the hydrogen, it is coming out from this side, in that we are adding ethylamine also. So in the ethylamine, this hydrogen, deficient electron hydrogen, it is being added to the nitrogen of ethylamine. So we are getting here CH3, CH2, NH3 plus. Okay. And our main product, what we are getting here, CH3 single bond C, double bond O, single bond N, single bond S, single bond CH2, CH3. It is named as N-ethyl acetamide. Like this also we can represent in the mechanism, as we are getting this, as we are taking this particular compound, that is CH3 single bond C, double bond O, single bond N, single bond H, single bond H, then single bond CH2, CH3. So what will happen here, in between nitrogen and hydrogen, one single bond is there, na? That bond, it is shifted towards the nitrogen. Okay. And this hydrogen, it is coming out as a electron deficient compound. So what will happen? This H plus reacting with Cl minus, and we are getting HCl as a side product, and our main product is N-ethyl acetamide. Next chemical property we will see, that is carbylamine reaction. Ethylamine, on heating with chloroform and alcoholic potassium hydroxide, forms an isocyanide called carbylamine, having an offensive smell. See the reaction here. C2H5NH2, ethylamine we are taking. In that we are adding chloroform, CaCl3 and 3 moles of potassium hydroxide, and we are providing heat. Then what will happen? Ethylamine is there. Now from ethylamine, the 2 hydrogen atoms are coming out. In place of that one carbon from chloroform, it is going to attach to the nitrogen, and we are getting this product C2H5NC, which is named as ethyl isocyanide. Then 3 potassium reacting with the 3 chlorine, and we are getting 3 moles of potassium chloride, and another side product is 3 moles of water. Now we will see the mechanism. Potassium hydroxide on ionization gives K plus plus OH minus. Then as we are getting hydroxide add OH minus, this one we are adding to the chloroform. We are adding the chloroform in the expanded form, C single bond H, Cl3. Then in between carbon and hydrogen, one bond is there, na? That bond, it is going to shift towards the carbon. So carbon is showing the negative charge with 2 electrons, and hydrogen is becoming electron deficient, so it will carry a positive charge. Positively charged hydrogen reacting with OH minus, and we are getting the side product as water. And our main product is carbon with the negative charge with 2 electrons reacting with the, and it is attached with the 3 chlorine. Okay, single bond Cl, single bond Cl, single bond Cl. In the expanded form we have. So then in this particular compound, what will happen? In between carbon and chlorine, bond is there. Now that bond it is shifted towards the chlorine. Means the chlorine it is coming out along with the bond. So we are representing here Cl with 2 electrons negative charge. Chloride ion is coming out. And what is remaining there? CCl2 with 2 electrons. It is known as dichlorocarbene. This dichlorocarbene we are adding to the primary amine, that is RNH2. RNH2, in the expanded form we have written the structure of primary amine, R single bond N, single bond H, single bond H, on nitrogen, lone pair of electrons. Okay, then this lone pair of electrons which are present on the nitrogen atom, it is forming a bond with the dichlorocarbene. Okay, so we are getting this structure, R single bond N, single bond H, single bond H, then single bond CCl2 on carbon, electron pair with negative charge, and nitrogen is becoming electron deficient, so it will carry a positive charge. Then next, what will happen in the next step on reversible equation? Hydrogen, it is coming out by leaving the bond here itself with the nitrogen. Okay, that bond we are representing on nitrogen as lone pair in the next step. Then as the hydrogen is coming out by leaving the bond here itself with the nitrogen, hydrogen is becoming electron deficient. So it will carry a positive charge. So positively charged carbon attacking on the positively charged hydrogen is going to attack on the negatively charged carbon. So we are getting here CH, then single bond Cl, single bond Cl as it is. Then in this particular compound, what will happen? One of the chlorine, okay, it is coming out along with the bond. So we are representing here, we are getting the chloride ion as its side product here. And at the same time, lone pair of electrons are there on the nitrogen. Now it is forming a bond in between nitrogen and carbon. So double bond we are representing, and on nitrogen the positive charge is created. Then in the next step, what the product we are getting in this second step, now that we are taking as a reactant. Then from this, what will happen? As we can see here, in between nitrogen and hydrogen, a bond is there. Now that bond it is shifted towards the nitrogen. So hydrogen is coming out by leaving its bond along with the nitrogen. So what will happen in the next step? R single bond N with the electron pair, then double bond is created here, then single bond C, single bond H, single bond Cl, and the hydrogen electron deficient hydrogen already we are representing here on the arrow, minus H plus, it is coming out. Next step, what will happen here? Look at this very carefully. Lone pair of electrons which are present on the nitrogen, it is sharing and pairing and forming a bond in between nitrogen and carbon. So you can see here that triple bond is created in between nitrogen and carbon, and nitrogen is showing electron deficiency. Then at the same time, the chlorine from this side, it is coming out along with the bond. So we are representing on the arrow, that is minus Cl minus and with the electrons. So remaining here what? R single bond N, triple bond C, single bond H. On nitrogen, positive charge. Then in this particular compound, we are adding OH minus ion. So what will happen? Hydrogen, it is coming out from this side by leaving the bond here itself with the carbon. So H plus reacting with OH minus, and here we are getting the side product as water. And the bond it is formed on the bond, it is shifted towards the carbon. So here we are representing R single bond N with the positive charge, triple bond C with the 2 electrons negative charge. Okay, so it is known as alkyl isocyanate. Next reaction we'll see, that is Ginsberg's separation method. The mixture of 3 types of amines is treated with Ginsberg's reagent. Ginsberg reagent is nothing but benzene sulfonyl chloride. Primary and secondary amine react with it, while tertiary amine remains unreacted. See the reaction here. primary amine we are taking R and H2 will be there. In the expanded form we are adding R and HH. It is the primary amine. In that we are adding benzene sulfonyl chloride C6H5SO2Cl. So what will happen? From primary amine, one hydrogen is coming out, reacting with Cl of benzene sulfonyl chloride, and we are getting the side product as HCl. And the rest of the things are as it is. So here, what we will get the product? R and H. Okay. Then this one, C6H5SO2 remains here. Now it is turning and attaching as SO2 C6H5. So we are getting the product which is named as N-alkyl benzene sulfonamide. Next we will talk about the secondary amine. We'll take the secondary amine, that is R2NH. In that we are adding benzene sulfonyl chloride, which is nothing but Hinsberg's reagent. So what will happen? From the secondary amine, hydrogen is coming out, reacting with Cl of benzene sulfonyl chloride, and we are getting the side product as HCl. Then our main product is R2N. To this particular R2N, SO2C6H5 is going to attach. So we are getting this compound which is named as N-dialkyl benzene sulfonamide. In the above mixture, some sodium hydroxide solution and ether are added. Sulfonamide dissolves and forms its sodium salt. How we will see here? RNH SO2C6H5. In that we are adding NaOH. So what will happen here? From this side, one hydrogen is there. Now, this hydrogen, it is reacting with OH of NaOH, and we are getting the side product as water. And in place of this hydrogen, Na is substituted there. So we are getting this compound, this product Rn. In the bracket we are mentioning this one Na SO2C6H5. This is sodium salt. Aqueous lower layer. In the aqueous lower layer, we are getting this sodium salt. So sulfonamide from secondary amine and unreacted tertiary amine dissolves in ether and forms the upper layer. The two layers are separated. The aqueous layer is acidified with dilute hydrochloric acid and then hydrolyzed with concentrated hydrochloric acid. It is then distilled over sodium hydroxide when primary amine passes over. So here we are taking Rn Na SO2C6H5. In that we are adding HCl. So what will happen? This Na, it is reacting with Cl of HCl, and we are getting the side product as NaCl. And in place of Na, hydrogen from the HCl is substituted there. So we are getting this product RNH SO2C6H5, which is named as N-alkyl benzene sulfonamide. Then this N-alkyl benzene sulfonamide we are taking. In that we are adding HCl and water molecule. Then what will happen here? R and H will be there. Na? In that one hydrogen from this side, from water, one hydrogen is being added there. So R and H2, then this HCl. That is named as primary amine hydrochloride. Along with that we are getting the side product C6H5 SO2OH. This is named as benzene sulfonic acid. Then in the next step we are taking RNH2 HCl, that is primary amine hydrochloride. In that we are adding sodium hydroxide. Then what will happen here? Na of NaOH reacting with RNH2 HCl of Cl, and we are getting the side product as NaCl. Okay. Then this OH reacting with H, and we are getting the what? H2O. And what is remaining there? RNH, that is primary amine. The ether layer is collected. Fractional distillation will take place when tertiary amine distills over. The remaining sulfonamide of secondary amine is treated with concentrated hydrochloric acid. So here you can see the reaction R2N SO2C6H5, that is named as dialkyl benzene sulfonamide. In that we are adding HCl and water. What will happen here? We are getting the main product as C6H5SO2OH. It is named as benzene sulfonic acid. Another our product is R2NH HCl, which is named as dialkyl amine. Dialkyl amine hydrochloride, which is nothing but secondary amine hydrochloride. Okay. That dialkyl amine hydrochloride, in that we are adding sodium hydroxide. Then what will happen? Na of sodium hydroxide reacting with the Cl, and we are getting the side product as NaCl. OH of NaOH reacting with H of HCl, and we are getting water. Okay. Then what is remaining there? R2NH, which is nothing but secondary amine. Next reaction we will see, girls, that is reaction with nitrous acid. Primary amine react with nitrous acid to form alcohol with the liberation of nitrogen. See the reaction? C2H5NH2. It is named as ethylamine. In that we are adding nitrous acid, that is HNO2. In the expanded form we are writing HONO. Reaction will take place in the presence of NaNO2 and HCl. Then what will happen here? From ethylamine, NH2 it is coming out. Okay, NH2 it is coming out. In case of that one, OH from nitrous acid is substituted here. So C2H5OH, ethyl alcohol we are getting. Along with that, this nitrogen and this nitrogen, it is coming out as nitrogen gas. Along with that, we are getting water molecule, H2O. Then secondary amine, when react with nitrous acid in presence of NaNO2 and HCl, it will form N-nitrosamine. So how we will see the reaction? CH3 taken to ice and H. See this reaction, girls. CH3 taken to ice and H. This is named as dimethylamine. In that we are adding nitrous acid, HONO. In the expanded form we are adding, and this reaction will take place in the presence of NaNO2 and HCl. Then what will happen here? Look at this. Dimethylamine is there. Now from that, this hydrogen it is coming out. Okay. Reacting with OH of nitrous acid, and we are getting the side product as water. Then what is remaining there? CH3 taken twice N. Okay. To which this nitrogen is attached. Single bond N with this nitrogen double bond O. So it is named as N-nitrosodimethylamine. So the tertiary amine react with nitrous acid, forms addition salt. How? Look at this. CH3 taken thrice N. It is named as trimethylamine. In that we are adding nitrous acid, HNO2. Reaction will take place in the presence of NaNO2 and HCl. Then this nitrous acid, it is being added to the trimethylamine. So we are getting this product, square bracket CH3 taken thrice and H plus square bracket closed NO2 minus. It is named as trimethyl ammonium nitrite, which is nothing but addition salt. Thank you for listening my lecture, girls.